Now we're going to hear from another keynote from another expert in their field. She's even been on BBC Click before, and she's amazed people with her work, which ultimately helps people find their voice. Annalu Waller, PhD, OBE, is Professor of Human Communication Technologies and the Academic Lead for Computing at Dundee University, Scotland. She directs the Dundee Augmentative and Alternative Communication, AAC, Research Group, and she's worked in the field of AAC since 1985, designing communication systems for and with non-speaking individuals. Her primary research areas are human-centered computing, natural language processing, personal narrative, and assistive technology. In particular, she focuses on empowering users and including disabled adults and children by involving them in the design and use of technology. Please do send in your questions for our final keynote, and I'll get around to asking them after Annalu's talk. But now it's my total pleasure to welcome to the stage Professor Annalu Waller OBE. Yes. Welcome, Annalu. And this is for you.
Thank you.
You're very welcome.
Although I'm also a pretty good driver. Good afternoon, everyone, and thank you so much for this opportunity to share with you. Oops, I'm not sure, but I think the automatic timing has been put on. Can we maybe switch it off on the PowerPoint? Technology has failed again. By the way, I hate technology. So can the guys behind please go into the PowerPoint and switch it off? Thank you so much. This is why technology needs support. Even when it works, you need other people. So, let us begin. Thank you again. My work in... Now I can't move it forward.
Oh, they're just taking the timings off, Annalu. 1 minute.
Oops, I'm too quick.
Stand by.
Oh, see, never perform with children, animals, or technology. And never do live demos because they always fail. So while I'm waiting, I can perhaps preempt the first slide to say that my work has been looking at assistive technologies and the use of high-tech computing to support things like mobility. You can drive wheelchairs with your eyes or your mind. We're also using robotics for things like daily living activities in order to feed oneself. The Internet of Things has revolutionized the way that people with complex and severe disabilities can live independent lives. And in addition, the access to the digital world for the first time ever provides an opportunity for disabled people to operate on a level playing field. The big issue is that we need to provide accessible interfaces to enable people to access those technologies. Now, what I'm going to talk about today is primarily related to what we call AAC, the use of low-tech paper, gesture, through to high-tech speech output systems to support people with no spoken voice or very difficult to understand voice. And this is the area I've been working in for the past 40 years. So there must be something in here if I've actually kept going for so long. And my purpose at the moment is to try and encourage younger professionals to take up the banner, because I'm going to retire soon and really start doing things. So the purpose of the research in Dundee, and we've had a continuous history of working in this area, is to harness the potential of very sophisticated computing, in today's terms AI, but make that technology accessible. So sadly, many data scientists and people working in AI work on the back end and seldom think about how people will use that technology to the ultimate. So in my area, we are trying to go beyond very slow communication into extended conversation. And we do that with and for people with complex disability. Back in the 1990s and the early 2000s, Dundee was really pushing a user-centered research approach, user-centered R&D. We can now retire because we've got Agile, and at the center of Agile is this awareness that we have to have this iterative way of developing usable software. It is no good having the most amazing facial recognition system if the law enforcement behind that system can't use the system. So we need to continually think about that user interface. So what I'm going to do now is give you 3 examples of projects that we've been involved in before I look at the implications for the mainstream technology. I met Professor Graham Ritchie in Japan, of all places, and he was demonstrating how a computer could create a joke. And he said, "We've proven we can do it. but why? And I stood up and said, well, I know. Our children need to be able to generate their own jokes. So the biggest issue here was developing an interface for children who couldn't read, who couldn't write, who couldn't talk, and had learning disability. So here goes. This is a wee video.
Say again, what do you call a spicy missile?
Spicy missile?
Yes, spicy
Say again.
What? Spicy missile? I have no idea. What do you call a spicy missile?
Okay. Say again. Okay.
No, it's difficult to get the okay at the right time.
Okay.
But she's fantastic.
First line. Last line. And hot shot.
A hot shot! Well done. That's very funny.
Say again.
And the jokes were awful. But actually, for these children, they were engaging in the same sort of language learning and language development as typical children. The challenge there was to create the interface with the child, and the video showed you in that process where we were actually doing this iterative development of the user interface with the child. So that's one project. The next project is something I've been working on for my whole career, since my PhD. And Nick will know a bit about this. We all tell stories. We are our stories. And this is where I sit up and think, I'm in good company, because people like Roger Shank have actually used the ability to tell story as being the ultimate in human intellectual endeavor. So until we can get systems to generate and understand personal story, we really haven't got artificial intelligence going. So that's a challenge for all of you. I need to enable non-speaking people to engage in personal narrative. They don't want to say, I'm thirsty, boring. They want to say, I saw Santa Claus last night, or things like that. So we're looking at how we can enable children to share their experience even when the listener isn't there. Because unless you know the topic, you are really stymied. So what we did, we actually went into a school and we put sensors throughout the school. We knew what the children were playing with, who they were talking to, what their timetable was, because stories are only stories if something exciting has happened out of the normal run-of-the-mill. We then collected the data and used very basic data to text to generate sentences for the children. Once again, the interface was the real challenge, and we developed an interface which you can see on the screen facing you. The young girl here is using a switch like Stephen Hawking did, so the system is scanning through options. Here goes.
Then I went to do your primary intel reading.
Great. Good. Junior primary. What about that was?
It is around there.
Oh, visitor. Right. What is it doing?
Dental hygienist came to give a talk.
Oh. Dental hygienist.
It is around there.
Oh. That was a visitor. Okay. That's why you went to junior primary. What did you think of the talk?
She's nice.
She was nice. That's good. Very good.
Now this looks very simple, but if you think that this young teenager could only normally say yes and no, because anything else took too long, she was actually controlling and driving that conversation. So one of my focuses has been to provide an opportunity for people to experience what a good conversation is. The partner hated this conversation because every time she asked a question, she thought, oh, she can't answer that. And yet, because conversation is very, well, it's not really there's no right and wrong about a conversation, which you can hear by the way I'm talking now. It doesn't matter how many mistakes I make, it's still a conversation. And it's experience rather than what's right and wrong. Also, the way we provide automatic feedback, like she is nice, only needs one button, a smiley face, to know that she was talking about somebody before, making a positive evaluation. She's nice. I like her. Wasn't she great? Those are all plausible evaluations for that. Finally, the Holy Grail. When we think about typing to communicate, we may be thinking of, hang on, I can type at about 100 words per minute. Talking is about 125, 185. Nobody types at 100 words a minute. Only touch typists. And then the average touch typists are only 40 words a minute. If you think about what to type, you go down to 22. So, a quick show of hands. Who knows how fast Stephen Hawking typed? Any shouts? 50 words? Who says 50 words or above? Lower? Okay, 25 words or above. 10 words or above. 1 word. You cannot talk it 1 word. I mean, even with prediction and scanning typists will only type it 2 words a minute. A keyboard user with hands like mine maybe types it 8 to 10 words a minute. Too slow. So we've been now working on ways to get phrases, sentences, and if you want to know more about this project, go and look at the Click program that was mentioned before. So, to end off, I just want to now look at why is this important for you folk? Why is this really important? It's important because we are all diverse. We are all different in our abilities, our culture, our gender, our language. And actually, we are all disabled. Every one of us is disabled at some time in our lives. And when you use little phone screens, you are disabled. So the better the design for the most complex disability, the better for all. In terms of AI, why AI? Well, I can give you a constrained environment to make things work. And we don't care if it goes wrong. We want that error in the system to allow children and people to learn. And finally, if we are really clever, we can use AI to actually level that playing field for health, for education, for employment, public services. These are citizens. We are all citizens of Scotland. We need to improve usability for everyone. But the danger is that if we don't do anything, that divide, we heard about the digital divide, will get bigger. And the only way we can reduce that divide is to begin including everybody, teenagers, children, older people, people with anxiety issues, people with mental health issues, people who are disabled. Because if we design for everybody, and we get them to participate in active ways, we can then create systems that work. But my final point, if we don't support that daily use, it all falls apart. Thank you.
Professor Waller, thank you so much for that. That was excellent, and I think we've got time for just maybe 1 or 2 questions?
Yes.
But we'll see how we get on.
We've also got the panel.
Yeah, well. But we've got you up here now. We've got some great questions from our audience in the room and at home for you here. And the first question I'd love to ask you is, we've talked a lot about trying to avoid bias in our AI tools. Co-design, co-creation was mentioned, but still maybe struggles to reach a wide enough population. How would you like to approach this huge challenge?
It's impossible to get it right for everybody, and we cannot include everybody in our design. Therefore, my view is, if you design for the most complex use cases, you will then design for more general use cases. So we've got to try and make sure that we tick as many issues around gender, culture, race, ability, age, but sometimes just looking at the most complex scenario will give you ideas for the mainstream.
Thank you very much indeed. And another question that's come through, of several, is do you think that, hold on, 2 seconds. Do you think that researchers and developers take the time to approach people with a range of communication needs? Are they unsure what to do, so nothing, and default to assumptions? Surely more accessible tech is better for everyone.
We scare people. I scare people. I don't know why. So that is one of our biggest challenges, is to break down the fear factor and to say to developers and researchers, go and visit your local special school. Go and work with daycare centers, work with disability organizations. We're out there, but people don't see enough of us.
Thank you so much, Annalu. I want to ask you, which advancement in technology, and particularly in assistive tech, excites you the most? Is there anything on the horizon that you've come across in your work, or anything that you go, oh, this could be a bit of a game changer here, or not?
Wow. I think we forget that a lot of the game changers began as assistive tech. So even ballpoint pens, typewriters, word prediction, all started as assistive tech and then have moved into mainstream. My biggest challenge has been watching people type for communicating, but then miss the predictions. And one of the biggest eye-openers for me is to sit back and take a totally new view on how we present prediction. How do we present AI data to the user? And we need to actually study how the user uses a device in order to work out how to best present the data. So we've done some eye gaze studies looking at how people use prediction, and they follow their fingers. They never look at the predictions. And we need to do more of that to go away from our assumptions as to how people use tech and really watch them.
Thank you so much, Professor Annalu Waller, everyone. Thank you so much. So you're going to stay here, and we've got other people now coming onto the stage. A little bit of stage management needs to take place with chairs and whatnot.